Hi, this is János, it's Real World Audio, and today we are looking at a Darling amplifier, a real Darling amplifier. And why is that? That's because Jürgen was asking János, how would you compare the sound of the modified Quicksilver rebuilt with the 807 tubes compared to the Darling amplifier, which with the 8532, which is a 6J4 military version, driving the 1626. So the 6J4 1626, that is the Darling amplifier, and usually people, myself included, call everything Darling which starts with that idea. So anyway, this is now the Darling. This was my buddy's Tamas's Darling amp. So when we built our Darlings, we built 3 identical Darlings, and this is one of them. This was still in the more or less original condition. I did some mods since then on it, but it still stayed a direct coupled double Darling basically. What does that mean? So it had 2 power tubes per channel, so it had double the power, so 1.5 watts per channel. And also the output tubes were direct coupled to the input tubes, and that's another thing. So there's no coupling capacitor in the signal path between these tubes. So that's a step up compared to the standard Darling topology. But I would say doubling the output tubes, doubling the power, is not a step up. People just think it's a step up, and at that time I thought when we built them that we are doing a step up, but it is not. It's just making it more compatible with dead speakers, but it's making it less transparent, less coherent, less deep. And actually sometimes you can use the extra power. However, here, even though we have a really big power transformer here, but that's still limiting the usefulness of the amplifier. And even though this is a pretty big piece of iron, but it was insufficient for a pair of output tubes. So what I'm doing is I'm doing a complete recap on it, and more than that, and I will just have 1 output tube per channel, just like the standard original Darling, 0.70 watt per channel, but direct coupled instead of capacitor coupled. And now I will have the same high voltage transformer supplying only 1 tube instead of 2, and it's drawing only 20 milliamps per channel, so 40 milliamps total plus driver tube, so that's less than 50 milliamps of high voltage total compared to the 90 milliamps including the 2 tubes. So I'm going to have quite a bit more dynamic reserve than what the amp had as the double Darling. So why we had it double Darling? Partially because of the really budget output transformer, which is the Hammond 125 ESE. And of course, when you double up the tubes, then you change the load that needs to be placed on the tubes from 10K to 5K, and that improves the bandwidth of these little beasties quite a bit. So my attempt here might backfire on me, because that 10K load might be something that is beyond the capacity of these output transformers. However, I'm quite confident that it will not be in vain, because I'm also halving the DC current running through these output transformers. So instead of 40 milliamps, there will be only 20 milliamps running through, and it means I'm getting a much bigger headroom for bass extension that was there before. And even though it has the puny little inductance, but that huge headroom for the magnetizable core that is given by only 20 milliamps current, that is giving me hopes of having a pretty decent bandwidth. And when you look at the label, you see it says there, if it's strong in focus, it's rated for, the air gap is designed for 80 milliamps DC. Now I will be running only 20 milliamps DC, so it means that I will have a much better bandwidth than is specified on the data sheet for this transformer, where the data is for that 80 milliamps being utilized. Also, this core is rated for 15 watts, and we are tasking it for 0.75 watts, which is 20 times less than it's rated for. So that's why in this duty, these Hammonds, which will perform way better in the bass department, in the headroom department, in the dynamics department, than what they are rated for. So if you don't have money to purchase like Tangos and Tamuras and whatnot, Hashimoto's, do not despair. These can do you pretty well as well. So anyway, this was Tamash's, so he built these, and when you look at it, some things are not like the straightest or the best looking, but I tell you guys that this was his very first job with electronics ever. So when he built this project, before that he did nothing at all, and I helped him out with the build, but the soldering bit he did it all by himself. So he bought himself a solder iron and he did it himself, and actually after he put it together, we tested it first together with me, and he perfectly put everything together. And he is not an engineer, nothing like that. He was a molecular biologist just like me. So anyway, this is now the rebirth of that amplifier. So because Jürgen was asking me how does the sound compare, and yes, I have memories that I can share, but I really wanted to share with all of you how does the Darling sound. And when you look at it, in my videos in my channel, I have shared a lot on how you can build your own Darling amplifier, and I gave recipes for the baby Darling, which is the canonical Darling amplifier, the actually what was the original Darling amp, using parts that are available today for everyone. So you can build that. And also I gave the pure Darling, which is a high-end version of that build, optimized for really high sound quality, and something that will give you a true little jewel that will be comparable, to give you a level of experience that you can expect from a $10,000 single-ended amplifier driving speakers that are matched for it. And this one is the one that I have called as the electric Darling, and I haven't given any instructions yet on how to build it, and that's because it uses almost double the high voltage compared to either the baby Darling or pure Darling, and this is not something that I would recommend as a first build, because the 265 volts DC of the Baby Darling or Pure Darling, that's enough. If you mess up, you get a nasty shock and you say ouch, ouch, ouch. But the 460 volts, 430 volts here, if you touch that by accident, then if you had heart problems or if you are unlucky or something, whatever, then it's your funeral. So that's why I am not recommending this to anyone who is not an expert. And this example says that Tamas, he built this. This was his very first project, but when he turned it on, when at that time, actually he did not turn it on, I checked everything out for him and we turned it on using that very same variac, that very same heat kit, and that's how this baby woke up for the first time. And I was there and guiding through the whole step, doing that step, and he was just watching. But if you want to build one, I am not there watching, and you can only build something like this if you are an experienced electrician. For first build, stay off. Even the Baby Darling and Pure Darling, I gave copious warnings to not to just do it by yourself, just enlist the help of someone and just be extremely precautious, because these are lethal voltages. If you touch them, you can get killed. And if you don't understand, then do not even attempt any kind of DIY work like that. So I think this is my video for today. As you see, I have halfway gutted it already. So there on that block of wood, that's where a bank of Sprague atom capacitors were sitting, and those are gone. And I also had the cathode bypass capacitors there for the power tubes next to the cathode bypass, the cathode resistor. Those are gone too. So I'm going to do some more surgery here, and I will show you what I have done, how it will turn out, and then I will share my thoughts on how it sounds, and I will also share sound samples. I will make recordings with the Darling, and I will also do that thing that I will play something with this Darling. That's 0.75 watts per channel, the same power output as Baby Darling or Pure Darling are. And I will also swap in the 807 Darling, where I change the power tubes from the 1626 to 807, which are bigger pentodes instead of these nice triodes. And that one gives about 2-3 watts per channel, and you can compare the difference between the two, and I will explain what other differences are, because they use the exact same output transformers, but there I have changed the power transformer to something much bigger, and the whole thing is fully silver wired. And here I'm going to keep the copper for a lot of the wiring, because if I would change it to silver, it would just take a very long time to just gut everything and redo everything, and I wouldn't be done with it before Christmas, I think. So thank you guys for tuning in. I hope this little video is of interest to everyone. Have a really awesome day. Bye bye.